Hi, I'm Anthony Geraldo-Frendo, and I'm the Customer Experience Center Prime at Ross Video. In this video, we will be covering the custom Tria VDCP Visual Logic workflow that I created. The goal of this video is to learn how to use the Visual Logic workflow tool to create more powerful server control custom panels. There is no skill requirement for this video, however, it would be a great idea to watch the clipless workflows videos and also the VDCP introduction and basic commands video. That way you can better understand the VDCP configuration that's needed on the Tria server. You can download this Visual Logic workflow by clicking on the link below this video if you're watching this on the Ross Video website. Now let's take a look at the two different methods that make up this workflow and how they work. Those two different methods are the device XML method and the external script file method. Each of these has a couple key points that breaks down why you might want to use one over the other. The first key point here is that the device XML file needs to be installed into your dashboard's installation for this to work. The external script file, however, does not, and it just needs to be co-located with wherever your .grid custom panel file is. Next, the Visual Logic Device XML works much better if you build it from scratch with the template panel that's provided. With the external script file method, it really isn't that difficult to add this to any existing panel because the process is as simple as adding an API tag to that custom panel and linking that API tag to your script file. The Visual Logic Device XML allows for a device definition, and this is really important because that means that you can declare the IP address of your device, versus the external script file method where the Visual Logic block now needs to define the IP address on it for each and every block you use. Last but not least, with the Device XML method, you get much more clean looking Visual Logic block with drop downs, checkboxes, and even help buttons for explanation on how this Visual Logic block works. When you look at the example of the external script file here, you can see that you just don't get all that functionality. You get a simple Visual Logic block with some type in text entry boxes that you can fill out. The last point I'd like to bring up is that with the external script file workflow, it can break your script because there is a known API function semicolon bug in dashboard. Although I have a quick fix for you that will solve this problem, and I'm going to show it in the example panel. So let's get started with implementing this workflow for ourselves. I have this open in front of me here. I just download this off the Ross Video website, and now all you're going to have to do is right click and extract that zip file into somewhere on your computer. So I'm going to extract all to my documents folder, let's say on my computer. So select folder and extract. Now that it's finished extracting, what we're going to do is we're going to add this custom Tria VDCP Visual Logic folder into our file navigator. So I'm going to navigate to dashboard. In the file navigator, I'm going to hit the plus icon here, and I'm going to select the custom Tria folder. Now that this folder has been added to our dashboard, we can get started with the device XML method. Again, like I mentioned in that diagram that I just showed you, it needs to be installed within the dashboard installation. To do this, there's a custom panel built called Tria VDCP Device XML config.grid. This one will allow you to do that installation process for you. You can now use the Upload Tria Device XML button here. Click that, and it's going to start publishing this into the dashboard installation. Once it's confirmed that that file has been published to the dashboard installation, it's going to ask you to close dashboard and relaunch it manually. So now that I've closed dashboard, I'm going to relaunch it myself from the taskbar here. And there we go. Now this device XML method has been installed into my dashboard. So the process to start any custom panel that you're going to build using this method would be to start with the Device XML template panel. The template panel is crucial. The reason you would start with this versus starting with any other new custom panel file is because this template panel starts with metadata in it that holds all the scripts for the entire protocol. So now, before we get started with creating this custom panel, what we're going to do is we're going to perform a file save as so that we don't overwrite the existing template panel, so we can use that for future custom panel builds. So now that we've got the Save As menu open, I'm going to navigate up to the documents folder where I've already created an example VDCP folder for all my custom panels that I'm going to create. I'm going to call this one device XML, and I'm going to save it. Now that I've performed a save as, and I know I'm not going to be overwriting my template panel, we can get started with adding our Tria as a device into our custom panel. To do this, we're going to create a button, and let's say this button is going to be our play button. So we're going to call this play, and let's say this is for channel A. We're going to add a task to that button, and within the Visual Logic task that we're creating here, we are going to, on the top left corner of this pop-up, use the devices and parameters plus button to now find our new Tria VDCP device type. Once you select that, you're going to give it a name of Tria, or really whatever you want to call that, and then input the IP address of your device. So mine is localhost because I'm actually on the Tria as we speak. I always recommend to create a parameter for this, because that way if you ever need to update the value of the IP address down the road, it's much simpler, because then you have to just modify the value of a parameter. I'm going to choose a nice looking block color to go with this, so I'm going to choose a baby blue here, and then I'm going to hit OK. You'll notice it didn't ask me for the port value or anything like that. That's something that's different with this workflow versus the basic workflow that you would have seen with just adding a regular VDCP device, where it asks you for the port. The reason being is because the Tria uses a port by channel basis. So whenever you fill out what the channel field is on the Visual Logic block itself, that will define what port we're communicating to. Now that we've added this to our custom panel, you have a view into all of the different commands that we have access to within this protocol, which you can see is much more vast than what we had in the regular VDCP workflow. So we have access to the queue command, the queue play command, requeue, play, continue play, pause, fast forward, rewind, and stop. Those are what I would refer to as our channel transport controls. And then from there, we have retrieving data based commands. So we have what is the active clip in that channel, and send that value to a parameter. Get the duration of a specified clip ID and send that to a parameter. Get the back time code and send that value to a parameter. Get the forward time code of that channel and send it to a parameter. We can also retrieve a clip position percentage and send that to a parameter value. This is good for showing you an indication of how far we actually are into the clip with a progress bar type workflow. We have a multi-get active clip data to params. This essentially allows you to do the getting clip position, forward time, back time, and active clip all in one block. Then following that, we have all the different clip list based workflows that are possible. So you could get a clip list and post it into an integer constraint parameter, a string constraint parameter, a string key value pair constraint parameter, and this is made for the tree widget. And then there's the clip list to string array parameter as well. So this is the power that is behind this workflow. But now let's look at how we would use this and implement this. So first we'll create our play button here to show you how this is working. So we'll add our play button, and you'll see it's as simple as now you get a drop down that asks you what channel do you want that to play to. So I'm going to play that to channel A. Perfect. Let's reorganize that, hit OK again, and now we have a play button for channel A of our Tria. So I could bring this down below. I'm going to minimize my file explorer. And when I hit play, channel A, you'll see that that corresponded and worked on our Tria channel A. So now to give you a better, quick example of how this workflow can work for you and how powerful it can be, we have this device XML example panel. And this example panel showcases each and everything that it can do in this workflow. The way this panel works is you're going to have to input the IP address of your Tria server at the very top. So I'm inputting localhost since I'm on my Tria currently. And then you have a channel control selection here at the top where you can say, what channel am I controlling and monitoring? So I'm going to control channel A for now. That's fine. And I can do a live data pull, which will show me the live data being fed from my Tria into my dashboard panel. So now I can see I currently have 62 content Furio montage loaded into channel A, and this is where it is timecode wise. How does this actually work on the back end? Well, there's a timer that's doing a data pull in the back end, and basically it's going to request all that information from the Tria every second. Okay, so we set that to a 1 second interval in the back end. If I enter edit mode, you can see that here. If I move to the timer tool, I have my Tria polling timer I created, and it's a simple clock that I'm using a repeat rate of every 1 second. And the task on that timer uses the multi-get active clip data to params block. The way this block works is actually quite complex in that you have to tell it which of these data fields do you want to query for. And also, when you first pull this block in, it's important to note that you won't be able to see all the data entry fields. So you can see I just added one of these blocks in, and you're seeing that I'm missing all the data entry fields that we see here above. You can actually find directions on how to get this these data entry fields here in the help button that comes with this. So there's a little help button at the top right corner of your visual logic block. It says to expand the block to see the data entry fields, you need to click on the visual logic block until it's got a yellow border, and then you're going to click and drag the bottom right corner to expand it. So now I've got this in focus with the yellow borders. I'm going to click and drag the bottom right corner out so I can see the data entry fields. The reason you were able to see that is because the names of each of these fields was too long to be able to show you the data entry fields themselves. So you can see the way this block works is we said we're going to allow it to pull the clip ID information. We are going to post that to the parameter with the OID active dash clip. So I have a parameter in my custom panel that has that. It's at the index of 0. If it's not an array parameter, you can pretty much know 100% that the default value here is 0. I'm going to pull the backtime timecode. So I have allowed that with this checkbox. I'm going to put in the OID of my backtime parameter. The index is 0, and I want to offset this by 0 frames, meaning I want to leave it as is. The pull the forward timecode, I've allowed this, and I inputted the OID. The index was 0 here. Let me put that back to 0. And I have an offset of -1 frames because I found that's what I needed to sync up my forward timecode. The pull clip list percentage has been turned on, and the clip list percentage to param OID is clip position. I didn't need to put any offset on this, and the final thing that's important here is that we sync up with the frames per second that is matching on my Tria server. Although what I've noticed is that 30 frames per second, even if you're in a different format, like currently I'm on 60 frames per second, works better because that's the frames per second that shows in the time code within the Tria interface. The reason you would use this multi-get active clip data to params block versus using any of the independent blocks for pulling clip ID into a parameter or time code into a parameter or the clip position into a parameter is because this block uses a single request to the Tria to receive all of this data. With the independent blocks, for example, getting active clip data and pulling that into a parameter, that is a single request that's being made. Therefore, if you were to have each of these independent blocks, that would be 4 independent requests that would be made to the server versus doing one single one to get all of that data. So if you're going to ask for more than one piece of information out of these 4 categories of data, it makes more sense to use this single multi-get active clip data to params block. So that would be pulling the live data into our channel transport so that we can use that for monitoring workflows. Next, we have the ability to check a clip duration, but you'll notice I have to specify what clip it is that I'm checking for a duration. To make this work, this little dropdown is actually technically linked to this clip list that we have here. I'm going to turn off my live data pull. That way I'm not overloading my server, because to pull a clip list, that is a lot of information it's asking. To do that at the same time as I'm doing a live data pull where I'm asking for new information every second can be quite strenuous on your server. So I'm turning off the live data pull, and I'm going to load my clip list, and I'm going to do this to each and every one of these. Each of these has its own benefit. The one on the left is probably the most basic and simple one to create, where it's just a string constraint parameter. There's not really too much to it. And we're using the list widget on this guy. In the middle here, we have our tree widget parameter. And this one's really nice because it allows for a folder-based workflow where we can expand and collapse folders inside of our clip list. The one on the far right is really nice because it's a table-based workflow. So it's an array parameter, but now I have this within a table, so I can create a clip list table with multiple data fields in it. So now that I've pulled in my clip list, I could use this drop down to find whichever clip it is I want that I want to check how long it is. So I could say I'm going to select the movie trailer Joshua, and we're going to check the clip duration, and that's 2 minutes, 18 seconds, and 2 frames. I can also utilize that same clipless workflow to load clips into my channel. So let's switch to channel B, for example, because we've been using channel A quite a lot. So channel B, I'm going to queue this Good Luck Chuck clip into that channel. So I'm going to queue that clip. And the exact same workflow can hold true with, all right, well, now I'm going to use this Cathedral Snow clip, and I'm going to queue play that guy. And you can see now it is playing, it's queued, it's in the channel. On the channel transport itself, we have all the channel transport base commands. So we could pause that channel. So now that clip has been stopped, I could rewind that channel. It's going to move the time code backwards. I could fast forward that channel, pause again, or just do a regular play. I can also re-queue this back to the top of the clip. So now I'm back to the top. Or I could eject my clip. So this is the power that comes behind this Visual Logic workflow that you've been given here. So now let's take a look at how we can build at least a basic clipless workflow panel from scratch, where we can have a clip list on the left side and queue it into a channel on the right. So now with this device XML panel, we've already added our Tria as a device into our custom panel. So what we're going to do is we're just going to move this play button we already created to the right hand side, and we're going to start by creating a clipless parameter that we can upload clipless data to. I'm also going to just close my device XML panel. That way I'm not overloading my Tria server with 2 different panels asking for information. And now I'm going to create my clipless parameter. I'm going to call it clip list. And the OID is clip-list. The data type that I'm going to set to this is string, and we are going to use the choice constraint parameter type. From there, you're going to have to give it at least one constraint, so I'm going to give it the constraint of please load the clip list ... And then I'm going to copy that constraint and put that as the initial value. That way, it gives an indication to the user that the clip list hasn't been pulled from the server yet and that they need to do that work. The last thing I'm going to do here is I'm going to set the widget type to list, and I'm going to commit my changes. So we have now created our clip list parameter. So now that we've created our clip list parameter, we're going to draw that clip list parameter into our custom panel using the params default tool. I'm going to put it in the left hand side here and choose clip list as the parameter we're dropping down. And before I move on with loading a clip list into this and creating a button for that, I'm actually just going to add the ability to have a scroll bar on this clip list parameter view by going into XML, and we're going to add the scroll attribute and set that to true. Apply and close. Now, anytime that there is more clips than can be shown within this clip list, it will add a scroll bar. So we're going to create a button now that will pull the clip list data and push it into this parameter. We are going to call this button clip list pull, or load clip list, that would be better. And we're going to add a task to this button, and that task is going to be the clip list to string constraint parameter, because that's the parameter type that we created. The way that we're going to do this is we're going to select what channel it is we want to interact with. You might be thinking to yourself, though, why would I want to have a channel selected for just pulling information from the server? The reason it's important is, as I mentioned before, the Tria uses a port by channel basis. So when we select that channel, it identifies which port is enabled for VDCP. So I know channel A is ready for VDCP, and the OID of the parameter I want to upload my information to is my clip-list parameter. So that's the OID of the parameter I just created. And you can check on the search message checkbox, and that will say that anytime you click this, it will show a message that you're searching for the clip list on your parameter until you get all the data you need. We're going to click OK. That's everything that needs to happen. And OK. And now, if I click this button, it should pull all that clip list data into our parameter here. It'll take longer for this to happen based on how long your clip list is. So keep that in mind. So now that I've gotten all my clip list data, I could utilize this in a clip list workflow where I select the clip on the left and queue it on the right. So with that in mind, let's create a queue button that uses whatever information I select on the left. We're going to create a button, drag and draw that out. So this is going to be queue selection to channel A. Going to add a task to that guy, and this is going to be our queue command. We are going to say this is a queue command to channel A, and we're going to fill in the clip ID field with our clip list parameter. Then we're going to turn on eject because we want this to kick out any clips that were previously in that channel and overwrite them with a new clip. Hit OK and OK. Now, whichever clip that I choose in my clip list will queue into my server. So I'm going to queue the cars clip. So let's just see that work here. I'm going to hit. So I made my selection of cars. I'm going to queue that to channel A. And now you can see that's gone through. You can use your play button even now to start that clip up. So this is a basic clipless workflow using the device XML method. Keep in mind, between the device XML method and the external script file method, they have access to all the same commands. The workflow of getting them to work just might be slightly different. So now that we've done the device XML, let's take a peek at how we would use the external script file API. We're going to open the external script file template panel. And within this panel, you might be thinking to yourself, well, why do I need a template panel? You said I didn't need one in the diagram. We still have it here in case you as a user like the workflow of having a starting point, a template panel to refer to. And it also helps you reference back and say, what is it that I need to do to get this connected up? So if you need to find out how you get this connected to a custom panel of your own, the way it really works is we have an API tag that lives within the metadata folder of our custom panel. And on that API tag, all that has been done is we located our external script file. So that is inside the same folder here. We have that placed. Tria VDCP external script file.js is the one that we're trying to point to. You can copy and paste this into the file directories for any custom panel that you've already created or you want to create and link it up the exact same way. The method to add an API to your own custom panel is just as simple as going to the top level ABS and clicking this API tag, and that will create a metadata folder for you if you didn't already have one, and now you have an API tag within that metadata folder and do that connection. So now let's take a peek at how this looks as far as when you're creating a button and adding tasks into that button. So let's say I was doing a play button, just like we did on the other panel. To do this, we're going to create our button. We're going to call this play channel B. And on that button, we're going to add a task. You'll notice we're not going to create a Tria VDCP device, but instead, what we're going to be doing is using this API functions folder that we get here on the right-hand side. And you're only going to get this API functions folder if you have done that API connection in the back end. It is the exact same commands that you get access to in the device XML that you get access to here, although this is organized slightly differently because it organizes these alphabetically. So to get the play command to work, we're going to do the VDCP Tria _ play command. And you'll notice I have to input the IP address of my server on the block itself. That's one of the key downfalls of this. So localhost, and then the channel letter is A. There I go. I'd hit OK. And actually, I'm just remembering now. The channel letter is B. You'd hit OK. Then you'd hit OK. And now we're going to see this would start up channel B for us. So let's just cue a random clip into there for now so we can see this work. And play channel B. So to give us a quick glance at how we can utilize all of these different commands within a custom panel, it's the exact same thing. We have this external API examples panel now. And in this examples panel, it gives you a brief description on how you would get this connected up for your custom panel if you needed to. With this, it's the exact same method. So you see that we have the live data pull. It can work the exact same. So we're going to first put in our IP address here. We're going to turn on our live data pull. And now we are pulling the live data from channel A, channel B, C, D, and so on. This is connected through a timer just the same as the device XML panel. But now you'll see that it's using one of these API function visual logic blocks that we've been referring to. With this visual logic block, it's not as pretty by any means as the one that you'd see in the device XML, but it does work. Instead of having a checkbox to the side if you want to pull the data from the clip ID, you would now have to put in true if you want to pull that. And you could leave it blank or write in false if you don't want to pull that information. And put the OID and the index just the same. And then true, true. So you can see here anywhere that previously had a checkbox on the device XML version of this block, it's now you just have to write out true. And that's what the TF stands for, true or false. You'll remember when I was showing you that diagram, I mentioned that this visual logic workflow for the script file API can technically break because there's a semicolon bug. That's why you're seeing here I put in a custom code block following this VDCP API block, and that's because it doesn't add in the semicolon on the back end for you. So this is the quick fix that I referred to. So you could find any of these custom code blocks just by searching on the right hand side here, custom, and then it'll pull up the custom code block that you could put in anything into. So I just put custom code and then dropped a semicolon into this custom code block. Hit OK, done. The way that this works is very similar across all of these as far as workflows go. So if you look at the queue clip block, we are now filling out the Tria IP address with the parameter for the Tria IP, the channel select parameter, and then we're using the string clip list. The rest of this custom panel works the exact same, it's just the visual logic blocks look slightly different. So let's just, as an example and as an exercise, let's build another clip list workflow panel, but using the external API version. So what I'm going to do is I'm actually just going to do an example of creating a whole new custom panel file. And I'm going to call this one my external script. In my external script panel, I'm going to double click anywhere using the select and drag tool. And I'm going to add in an API tag while I'm selected on the top level ABS in my tree. Now that I've done that, I'm going to browse a script file location to the script file that I had in that other folder. It's probably best if you want to copy the external script file that we have here into the same folder as I'm doing right now, that you have your current custom panel that you're trying to build with this workflow. So it's much easier to find. Now that I've copied and pasted that script file into the same folder as my custom panel file, when I hit browse, it's one of the first things that pop up here. I'll hit OK and open, and I'll apply and close those changes. So now I have added this workflow to my custom panel. I don't need to add the device or anything because you're going to declare that on the Visual Logic block itself, the IP address. So now, because we want to do a clipless workflow, this time we're going to do the tree folder version of this. To do that, we're going to create a parameter using the parameters tool in the toolbar. And we are going to call this clip list. And then we're going to give this the OID of clip-list. The data type is string, and the constraint type is string key value because we want to do the clip list tree. For this, I just try to do the same as I did before, but now you're going to have to do into two different columns here, one for value, one for name, and we're just going to write load clip list, please. Once you're done writing load clip list, please, into both of these sides, then we're going to also paste this into the initial value. That way the user knows that they need to load the clip list with the load clip list button first. The last thing we need to do now is we need to select a widget type, and the widget type we're going to use for this is the tree. Commit our changes. There we go. Now we have created our clip list parameter. And let's draw that into our custom panel using the params default tool. Clip list parameter, hit OK. And just the same as we did with the other parameter, we're going to double click on that, jump over to the source code tab, and add in the scroll attribute. Apply and close once we set that to true. And now, again, because we did that, if there are more clips than we can fit in our clip list, it will expand and give us a drop down. Now let's add a load clip list button into this custom panel. To do that, we're going to draw that just down below this clip list, and we're going to call this load clip list. Add a task to that button, and we're going to use the VDCP list clips to string tree param. With this, all we have to do is input the IP address of our Tria. So I'm going to put in localhost because I'm on my Tria currently. The channel letter I want to interrogate, so let's do a channel B, sure. And then this is going to go into my clip-list OID for my parameter. And then was the searching message I want to show. I'm going to write searching ... There we go. I'll hit OK and OK. Now once I'm done with all that, now I'm going to click my load clip list button, and that's going to start that searching process, and then it's going to pull up my clip list data for me. And we can see it's populated this in a file folder format. So now I can look through the different folders within my clip list and subfolders even, and then queue whichever clip I select. The process to get a queue clip button to work now is we're going to create a queue to channel B button here, and we're going to add a task on that button to load. So VDCP cube is the task we're going to do. We're going to put in our IP address here, and this is going to be for channel B. And the clip field, we're going to fill that out with our clip list parameter. So queue that specified clip. Hit OK, OK. And now whichever clip it is I choose in my clip list will be loaded to channel B. So I'm going to load my out of tunnel clip to channel B. Well, that's it. Thank you so much for watching. That has been the Tria VDCP visual logic workflow that I created. In the next video, we will be discussing how to pull clipless data from the Tria's video server using VDCP through scripting.